Hey guys, in this video I'm going to run you through all the solutions for 2023 Edexcel AS Paper 1. Every question is going to be timestamped so you can easily find a solution for a particular question. Hope you find this video helpful. Okay, so here's the front of the paper. If we go straight to question 1, it says a curve has equation y equals 2/3 x cubed minus 7 over 2x squared minus 4x plus 5. Part A then asks, find dy by dx, writing your answer in simplest form. So for part A, we're just going to use the power rule to differentiate. So 2/3 times 3 would leave us with 2, and then reduce the power by 1, that leaves us with 2x squared. Then we're going to have 7 over 2 times 2 leaves us with minus 7x, and then minus 4x just leaves us with minus 4, and the 5 differentiates to 0. Then for part B, it says, hence find the range of values of x for which y is decreasing. Well, the function is decreasing when the derivative is less than 0. So we need to see when our derivative, this quadratic, so 2x squared minus 7x minus 4, is less than 0. To solve a quadratic inequality, I'll always plot the graph. This one we can do quite easily if we just factorize quickly. So the factors are going to look something like this. And then if I put a minus 4 in here, that gets us to minus 8x. If I put a plus 1 in here, that's going to give us minus 7x. So we know we have roots for our quadratic at minus a half and 4. So if I make a quick sketch, minus a half, let's hit here, say, and then 4 here. It's a positive quadratic, so it's going to be a U shape, going through minus a half and 4. And then we're interested in where this quadratic is below the x-axis, i.e. less than 0. So that's going to be true when x is greater than minus a half, but less than 4. Okay, so now moving on to question 2. It says, using the substitution u equals root x or otherwise, solve 6x plus 7 root x minus 20 equals 0. Well, to use our substitution, u equals root x, we just have to note that if I square both sides, then u squared would equal x. So plugging both of these things into that equation, we'd have 6u squared plus 7u minus 20 equals 0, which we can actually factorize. So 3u and 2u are going to form part of the factors. And then if I put in minus 4 in there, that gives me a minus 8. And the other factor would then have to be a plus 5. And if I put that in there, that would give me a plus 15u. And plus 15 minus 8 will leave me with plus 7. So those factors work. So then we'd have u equals 4/3 or minus 5 over 2. And that's really the square root of x equals 4/3 or minus 5 over 2. But now we have to think, does it make sense for the square root of x to ever equal minus 5 over 2? Can we ever square root a number and get a negative out? Well, not for real numbers. So we're going to ignore that solution and just do the 4/3. If we want to solve for x now, we need to square. So if I square everything, I'd get x equals 14 over 9. Sorry, not 14, 16 over 9. Moving on now to question 3, we have figure 1 is a sketch showing the position of 3 phone masts A, B, and C. The masts are identical and their bases are assumed to lie in the same horizontal plane. From mast C, mast A is 8.2 kilometers away on a bearing of 72 degrees, and mast B is 15.6 kilometers away on a bearing of 39 degrees. Find the distance between masts A and B, giving your answer in kilometers to one decimal place. So first off, I'm going to draw that information onto the diagram. So if we put in mast B first, so that's this side of our diagram, then we'd have this distance is 15.6 kilometers. And this angle from north, the bearing, is 39 degrees. Then if we put in the other side of our triangle, C to A, its bearing is 72 degrees, but if we take away the 39 degrees already on the diagram, that would make this angle 33 degrees, and the length is 8.2 kilometers. And in part A, we're interested in the other side that I haven't drawn in yet, which is here to here. So we can see we have a problem, a triangle problem rather, but specifically we've got a side angle side situation, because we've got the side here, and the angle in between the two sides. So that's a side angle side problem, meaning we can use the cosine rule. So the cosine rule is as follows: c squared equals a squared plus b squared minus 2ab cosine c. And I'm actually interested in finding the remaining side c in my problem, so I'll square root. So c is the square root of a squared plus b squared minus 2ab cosine c. And then plugging our numbers in, I'll always write out the line of working that I'm going to put in my calculator. So that would be 8.2 squared plus 15.6 squared minus 6 squared minus 2 times 8.2 times 15.6 cosine of 33 degrees. So now go to your calculator, make sure you're in degrees, which I am. So then we're going to have the square root of 8.2 squared plus 15.6 squared minus 2 times 8.2 times 15.6 times cosine of 33, closing the bracket. That gives me 9.7997, and always check if there's rounding in the question. It asks for rounding to 1 decimal place. So for us, that's going to be 9.8 kilometers to 1 decimal place. Then part B says an engineer needs to travel from mass A to mass B. Give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travels. Well, a simple reason would be that's quite a relatively long distance. It's quite unlikely, even if he could, travel in a perfectly straight line, that he would. And he probably can't travel in a straight line anyway. So the line's probably actually kind of curved, which means our answer would be an underestimate. So our answer likely too small as engineer, unlikely to travel in a straight line. Moving on now to question 4. It says, for part A, sketch the curve with equation y equals k over x, where x is not equal to 0, and k is a positive constant. So that's a positive reciprocal graph. So if we draw some axes quickly, so this is for part A, my axes. A positive reciprocal graph looks something like this. And then part B says, hence or otherwise solve 16 over x. So that's a version of the graph we already have. Where is that less than or equal to 2? So for part B, I'm just going to do another quick sketch so I don't interfere with my answer for part A. But here's another quick sketch. And then y equals 2 runs along like this. And we're interested in where our reciprocal graph is less than or equal to 2. So that's this part of the curve. This part of the curve. and this part of the curve, including, because it's equal to, where it's equal to that dashed line of y equals 2. So this part is simple. That's just where x is less than 0 and not including 0 because the function's not defined there. And then this part, we need to find where this line intersects, which we can do just by solving where 16 over x equals 2. If we did that, that would be x is equal to 8. So then this section here is where x is greater than 8. So our solution, sorry, greater than or equal to 8, because it's a less than or equal to inequality. So our solution then would be x is less than 0 or x is greater than or equal to 8. So moving on now to question 5. We have the finite region R, shaded in figure 2, is bounded by the curve with equation y equals 4x squared plus 3, the y-axis, and the line with equation y equals 23. Show that the exact area of R is k root 5, where k is a rational constant to be found. Well, first thing is it's a curved area. So it's not a regular shape, so we don't have a formula for it. We need to use an integral. But an integral, the way we know how to use them currently, is just an area between the curve and the x-axis. So let's just draw a line down from here to the x-axis. So we could find this area if we work out some appropriate limits to with an integral. So we need to find this limit here, which is just when the curve is equal to 23. So let's start by finding that. If I set the curve to 23, so 4x squared plus 3 equals 23. Then we'd have 4x squared equals 20. Then x squared is going to equal 5. So x is going to be, well, it would be plus or minus root 5, but we can see clearly it's positive. So that's going to be root 5, the positive solution rather. Cool. So then we can find that shaded area, or the one I've just shaded in, between the curve and the x-axis with an integral. So if we integrate the curve from 0, because that's where it would start at the origin, to root 5, and it's the curve 4x squared plus 3 dx. Then using the power rule for integration, if I raise the power by 1, that would be 3, and then divide by the new power, so that'd be 4/3 of x cubed plus 3x. And that's between the limits of 0 and root 5. So I'd just like to take a step and just substitute the limits in. Don't try and do any calculations, literally just plug the numbers in. So plugging in the limits, that would be 4/3 of root 5 cubed plus 3 lots of root 5 minus, well, it's actually just going to be 0 in all of that because x cubed and x is going to give 0 for both of those terms. So that's quite nice. We don't have to worry about that second limit at all. Now we need to just simplify these limits. So root 5 cubed, if you go to the calculator, square root of 5, and then cube that answer, that's 5 root 5, and then multiply that by 4/3. Oops, 4/3. That gives us 20 root 5 over 3. So we've got 20 root 5 over 3 plus 3 root 5. So we take that 20 root 5 over 3 and add on 3 root 5, which is 29 root 5 over 3. But we're not quite done yet because we need to find the actual area they've asked us for. So that area R, we could find R by taking this rectangle here and subtracting the value of our integral. So that rectangle is just going to be 23 times root 5 minus the value of our integral, which was 29 root 5 over 3. So we're going to do 23 root 5, take away the answer from our integral, which is just going to leave us with 40 root 5 over 3. So k must just be 40 over 3. Moving on now to question 6. We've got the circle C has equation x squared plus y squared minus 6x plus 10y plus k equals 0, where k is a constant. Find the coordinates of the centre of C. Well, to find the centre, we need to put it into the nice form where we complete the square twice. So once for x and once for y. Completing the square, then I'd have x minus 3 squared. That gives me the x squared and the minus 6x, but I would not want the plus 9, so we'll take away 9. Then repeating the process for the y's, we'll have y plus 5, and again it gives me the y squared and the 10y, but I don't want the 25, so we'll take away 25 and put the k back in. So that's the equation of our circle. If we tidy up a little bit, just for later, x minus 3 squared, oops, got my squared sign there, and then y plus 5 squared is going to equal 34 minus k. So reading off from these two numbers, we know the centre of the circle would be 3 minus 5. Okay, now part B, it says, given that C does not cut or touch the x-axis, find the possible values for k. Well, that's going to be to do with the radius. So we know from the equation of our circle that 34 minus k is going to be the radius squared. And this info here is going to put a restriction on that. To see what it's actually going to do, let's draw ourselves a little diagram. So the center of 3 minus 5, let's say that lives about here, and we're not allowed to touch the x-axis here. That's 3 minus 5. So that means our radius is going to have to be at least smaller than 5. So r is going to be less than 5, which means r squared is going to be less than 25. So we know that 34 minus k then must be less than 25, meaning that k must be greater than 9. But another restriction that applies to any circle is the radius has to be bigger than 0. So let's see if that leads to anything interesting. So if the radius is bigger than 0, that means the radius squared is also bigger than 0. So that would be 34 minus k must be greater than 0. So that would mean k is less than 34. So it actually does put an upper bound on our value of k. So then k is going to have to lie between 9 and 34. Moving on now to question 7, it says the distance a particular car can travel in a journey starting with a full tank of fuel is investigated. From a full tank of fuel, 40 litres remained in the car's fuel tank after the car had travelled 80 kilometres. And from a full tank of fuel, 25 litres remained in the car's fuel tank after the car had travelled 200 kilometres. Using a linear model with B litres being the volume of fuel remaining in the car's fuel tank and D kilometres being the distance the car had travelled, find an equation linking V with D. So basically these are 2 points here. We have the distance and the volume left. So for this one, the first bullet point, the distance is 80 kilometers travelled with 40 litres left. And in this one, it's 200 kilometers travelled with 25 litres left. And a linear method, that's just a straight line equation. So we can find the gradient of the straight line by using our points. So the gradient is y2 minus y1 over x2 minus x1. So that's going to be, let's take point 2 to be this one. So that'll be 40 minus 25 over 80 minus 200, which would be 15 over minus 120. And we just pop that in the calculator to simplify it. So what is 15 over 120? It's an eighth. So this is minus an eighth. So our equation must be something like v equals minus an eighth d plus a constant. To find the constant, let's just plug either of the points in. I'm going to plug in the point 80, 40. So 40 is going to equal minus 1/8 of 80 plus c. Minus an eighth of 80 is just minus 10. So take that over to the other side, then we'd have c equals 50. So our equation then is minus an eighth d plus 50. Let's write that a bit better, actually. Let's write the full answer properly here. So v is minus an eighth d plus 50. Right, then B part 1 says, find according to the model the initial volume of fuel that was added in the fuel tank of the car. So that's when the car's traveled no distance. So we can get that just by subbing in when d equals 50. Sorry, when d equals 0, excuse me. And we get the volume of the tank to be 50. And I always state the units in this. So that'll be 50 litres is the units they've used. And then part 2, it says the distance the car travelled on this journey. And it says, earlier it says the car continued until it ran out of fuel. So if it runs out of fuel at the end of the journey, there's going to be 0 fuel remaining. So if we set v equal to 0, then we'd have minus an eighth d plus 50 equals 0. So then d is going to wind up being just 50 times 8. So 50 times 8 is 400. And that's kilometers. Then it says, in fact, the car traveled 320 kilometers on this journey. Evaluate the model in light of this information. Well, 320 kilometers is significantly less than 400. So it's not a very good model. The values measured aren't matching up well to the values predicted by the model. So this is part C. So value predicted much greater than measured value. That's right, isn't it? Yeah. 400 kilometers to 320, yeah. So value predicted much greater than measured value, so model is no good. Or is not good. So moving on now to question 8. It says figure 3 shows a sketch of a curve C and a straight line L. Given that C has equation y equals f of x, where f of x is a quadratic expression in x, and C cuts the x-axis at 0 and 6, L cuts the y-axis at 60 and intersects C at the point 1080. Use inequalities to define the region R shown shaded in figure 3. So if we're going to define that inequality, which is bounded by those lines, we're going to need to know the equations for the curves or lines. So let's start with the quadratic. So they say it intersects at 0 and 6, so the roots are in 0 and 6. So for C, the curve must have factors, the equation, sorry, must have factors of x and x minus 6, but we could multiply that by a constant, any constant, and it will still have those factors. So we need to think about what constant actually fits the graph. And to do that, we can just plug in a point that we know it goes through. So we know it goes through the point 1080. So we'd say that 80 must equal a times 10 times 10 minus 6. So that's simplifying 80 equals a times 40. Yeah. So then a would equal 2. So our curve is y equals 2 lots of x times x minus 6. And then L is a straight line, so it's a straight line equation, y equals mx plus c. We can find the gradient because we know 2 points. So let's start with that. So for L, the gradient is the rise over the run. So this is the point 0, 60, excuse me. And this is the point 1080. So if we do the rise, which is going to be 80 minus 60 over the run, which is just 10, we're going to get 20 over 10, which is just 2. And then the y-intercept, the plus c, is actually given us for us because that's a point we have on the graph. So our equation for L must be y equals 2x plus 60. And then the shaded region that we're after here, well, that's where the y-coordinates are below the straight line, but above the quadratic. So that means y is greater than 2x x minus 6, but less than 2x plus 60. Moving on now to question 9. It says, using the laws of logarithms, solve the equation 2 log base 5 of 3x minus 2 minus log base 5 of x equals 2. So to solve a logarithmic equation like this, we need to use our log rules and combine the logs. We can't use the subtraction rule until we deal with this 2. So we can bring the 2 in as a power first. So that would be log base 5 of 3x minus 2 all squared minus log base 5 of x equals 2. Then using the subtraction rule, which just means we divide the arguments of our logarithms, we'd have log base 5 of 3x minus 2 all squared over x equals 2. And it's log base 5 of all that equals 2. So 5 squared is equal to everything in that logarithm. So 3x minus 2 all squared over x equals 5 squared. So that looks horrible, but the highest power of x in all of that rather, is just x squared. So it's a quadratic overall. So if I multiply by x and expand that bracket, I would have 9x squared, then minus 12x plus 4 equals 25x. Subtracting over the 25x, I would get 9x squared minus 37x plus 4 equals 0. Then I can factorize that, so it would be a 9x and an x. And if I put a minus 4 in here, that gets me all the way to minus 36, and the minus 1 in there gets me my plus 4 as well as another minus x to go to minus 37x, so that works. So the solutions then look like a 9th or 4, but you have to be careful and always check the solutions if they work in the original logarithmic equation whenever you get a question like this. So actually I can see if I plug a 9th in, that gives me a problem with this guy here, because if I do 3 times a 9th minus 2, that's just going to be a third minus 2, which is minus 5 thirds. but more importantly, it's negative, and we can't do a logarithm of a negative number. So we're going to exclude that solution. So it's actually just 4. Moving on now to question 10. It says the line L1 has equation y equals 3/5 of x plus 6. The line L2 is perpendicular to L1, that's important information, and passes through the point 80 as shown on the diagram. So that's the point 80. Show that the equation for the line L2 is 5x plus 3y equals 40. Well, L2 is just another straight line, so it's going to have the equation y equals mx plus c. We know the gradient already because it's perpendicular to L1. So if L1 has a gradient of 3/5, then L2 must have a gradient of minus 5/3. So our equation is going to be y equals minus 5/3 x plus c. And then to find the plus c, we can always just plug a point in. So plug in the 80, we'd have 0 equals minus 5/3 times 8 plus c. If we solve that, 5 times 8 is 40. Then bring it over, the c would be 40 on 3. So that would mean y is going to be equal to minus 5/3 x plus 40 on 3. And if we just multiplied everything by 3 and then bring over the 5x, we would have the form they ask. So let's write that. 5x plus 3y then must equal 40. Good. Then it says, given that lines L1 and L2 intersect at point C here, line L1 crosses the x-axis at point A. Find the exact area of the triangle ABC, giving your answer as a fully simplified fraction in the form P over Q. So that's this triangle here, where we're going to need to find the coordinates of A and C to work out the base and the height of our triangle. So let's start by finding A. That's just where the y-coordinate of L1 is 0. So if we go to L1 and set the y-coordinate to 0, so that would be 3/5 of x plus 6 equals 0. That's going to give us x is going to be minus 6, and then we're dividing that by 3/5, which is minus 10. And then to find point C, we're going to need to solve our equations simultaneously. So my equation was minus 5/3 x plus 40 over 3. So minus 5/3 x plus 40 over 3. And we're going to set that equal to, or substituting out the y's, in other words, the other equation, 3/5 of x plus 6. So tidying up now, if I bring the 5/3 over, so that would be 3 over 5 plus minus 5 over 3. Sorry, plus 5 over 3, excuse me. Yeah, that's 34 on 15x. So we'd have 40 over 3 equals 34 on 15x plus 6. Taking the 6 over, so that's, if we have 40 over 3, take away 6, we'd have 34 over 15 x equals 22 over 3. And then we need to divide that 22 over 3 by our 34 over 15, which is 55 on 17. So if x is 55 on 17, well, if I want the y coordinate to get the height of my triangle, I need to find the y coordinate. So I'll plug it back into either of the equations. I'm going to pick the 3/5 x plus 6. So y would then equal 3/5 times 55 over 17 plus 6. Plugging that in a calculator, so 3/5 times 55/17 plus 6 equals 135 on 17. And now that's the height of our triangle. The base is going to be the distance from A to B. So the base we can get to be, it's going to be 8. Well, it goes from -10 to 8. So the base is just 18. So then our area is a half base times height, or a half times 18 times 135/17. So plugging that in a calculator, a half, times 18 times 135/17 gives me 1215/17. Moving on now to question 11. It says the height h meters of a plant t years after it was first measured is modeled by the equation h equals 2.3 minus 1.7 e to the minus 0.2t, where t is a real number and greater than or equal to 0. Using the model, find the height of the plant when it was first measured. So that's easy. That's just when t equals 0 is when it would be first measured. So h of 0 is just 2.3 minus 1.7 e to the power of minus 0.2 times 0. So that's just e to the 0. E to the 0 is 1. So that's just minus 1.7. So that would be 0.6. And let's check the units. That's in meters. Then it says, show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimeters per year. So that's a rate of change of the height. So that's going to be the derivative. So we need to differentiate. So for part B, dh by dt, if you remember our rule for differentiating exponentials, we bring down that minus 0.2 and multiply, and the e to the minus 0.2t will remain the same, and then 2.3 just differentiates to nothing. So we'd wind up having positive 0.34 e to the minus 0.2t, and then we want to see what that is 4 years after. So checking the units again, t is measured in years, so that is just when t equals 4. So when t equals 4, we have dh by dt is 0.34 e to the minus 0.2 times 4 would be 0.8. So we plug that in a calculator. We'd have 0.34 e to the power of minus 0.8, which is 0.1527. Did they ask us to round? No, just so it's approximately 15.3. So, oh, that's something actually. So it rounds to 0.153, but that's in, we check the units again, that's in meters. So that's meters per year. So if we do adjust the units, that would be 15.3 centimeters per year. Now it says, according to the model, there is a limit to the height to which this plant can grow. To deduce the value of this limit. So a limit, we need to see what's going to happen as we let the plant grow and grow for as long as it likes to. So that's when t gets very large, or in other words, when t tends towards infinity. Well, if we look at our function for the model, so h of t is 2.3 minus 1.7 e to the minus 0.2t. The only thing that depends on t is this guy here. And we should know what a decaying exponential graph looks like. So e to the minus kx looks something like this. So it decays towards 0. So as t tends towards infinity, e to the minus 0.2t tends towards 0. And then if that bit's just 0, all of this just doesn't matter. And we're just left with that 2.3. So the height would tend towards a limit of 2.3 meters. Moving on now to question 12, it says, show that the equation 4 tan x equals 5 cos x can be written in the form 5 sine squared x plus 4 sine x minus 5 equals 0. So to do that, we're going to use the identity where tan x equals sine x over cos x. So if you sub that in to start off with, we'd have 4 sine x over cos, this is part A, sine x over cos x equals 5 cos x. Multiplying up by cos x, we would have 4 sine x equals 5 cos squared x. And then our answer is only in terms of sine, so we need to convert that cos squared into a sine squared x. We can do that with this identity, cos squared x plus sine squared x equals 1, or in other words, cos squared x equals 1 minus sine squared x. So substituting that in, we get 4 sine x equals 5 times 1 minus sine squared x. Then I would have 4 sine x equals 5 minus 5 sine squared x. And then bring it all to the other side, we'd have 5 sine squared x plus 4 sine x minus 5 equals 0. So part B then says, hence solve that equation. So that's the same as just solving the result we just found between 0 and 360 degrees. So what we have here is a quadratic in sine. If it helps you, you could say u is sine x. And then this would be 5u squared plus 4u minus 5. And for this one, I'm going to allow myself just to use the quadratic solver because we're really interested in the solutions of a trigonometric equation. So go to menu, scroll over to equation and functions, polynomial degree 2, type in my solutions. So that's going to be, sorry, my coefficients rather. So 5, 4, and minus 5. And we'll get our first root is at minus 2 plus root 29 on 5, which is actually what sine x is equal to. So we get sine x equals minus 2 plus root 29 over 5. And the if I hit equals, I'll get the other solution, minus 2 minus root 29 on 5. So we have another solution of sine x equals minus 2 minus root 29 on 5. So if I actually type in minus 2, try again, minus 2 minus root 29 over 5. That's minus 1.477. So the important thing there is it's smaller than minus 1. So that's not a valid solution for sine x because it only goes between minus 1 and 1. So we can actually ignore that. And we just have to focus on finding the values that's for x that solve that equation. So if I bring that over, that was sine x equals minus 2 plus root 29 over 5. And then let's draw a quick sine graph so we don't make a mistake. So there's a sine graph. Let's say minus 2 2 plus root 29 on 5 lives about there. And we're interested in these two values. So to get the first one, we can just do inverse sine of minus 2 plus root 29 on 5, and we'll get this value here. So let's do that. So minus inverse sine, sorry, of minus 2 plus root 29 over 5. That gives us 42.6122. I'm just going to write down plenty of decimal places right now. We'll check the rounding they asked for in a minute. So 42.6122. And then, so that's this solution here. We'd like this solution. So to get to that solution, we can subtract 42 from 180, which lives here because of the symmetry of the curve. This distance is the same as this distance. So if we do 180 minus that, minus the answer, that's 137.388877, blah, blah, blah. So 137.387779. Let's go back and check the rounding. They want one decimal place. So that's going to be x is equal to 42.6 and 137.4. Now it says, hence find the number of solutions of the equation 4 tan 3x equals 5 cos 3x in this really large interval now. So this thing, it says hence, so it's related to the last question. It's in fact the same as the question we had a moment ago, except the x's have become 3x. So basically, we'd be solving sine 3x equals minus 2 plus root 29 on 5. And we want to know how many solutions there would be in this interval. So first thing is, how does a sine 3x graph differ from a sine x graph? Well, it's a stretch. If we said f of x was sine x, that would mean f of 3x is sine of 3x, which means the graph has been stretched by a scale factor of a third, so squished, effectively. So if the graph normally repeats every 360 degrees, divide that by 3, that's how often it's going to repeat now. So 360 divided by 3, that is 120 degrees. And we're interested in the number of solutions from 0 to 1800 degrees. So let's just see how many repetitions of the graph of sine 3x we can get into that. So if we do 1800 divided by 120 degrees, that's how many repetitions of the sine graph we could fit into that interval. What's that? My brain doesn't want to do that right now, apparently. 1800 divided by 120. That's 15 repetitions. So then in each repetition, there's 2 solutions like we saw here. So 15 repetitions, 2 solutions, that would be 30 solutions total. Moving on now to question 13. It says, relative to a fixed origin O, point A has position vector 10i minus 3j, B position vector minus 8i plus 9j, C position vector minus 2i plus pj, where p is a constant. Part A just asks, can we find the vector AB? But to find the vector AB, we simply subtract some position vectors. So AB for part A is going to equal OB minus OA. which is minus 8i plus 9j minus, brackets so I don't make a mistake, 10i minus 3j, and then minus 8 minus 10, that's minus 18. We have minus 18i, and then 9 minus minus 3 is going to be 12, so plus 12j. Then part B says, find the length of AB, giving your answer as a fully simplified surd. To find the length, we just use Pythagoras' theorem. So using that, the length of AB is going to be equal to the square root of minus 18 squared plus 12 squared. And plugging that in the calculator, plus 12 squared, we get 6 root 13. Cool. So then moving on, it says, given that points A, B, and C lie on a straight line, C part 1 says, can we find the value of P? And part 2 is state the ratio of area of triangle AOC to the area of triangle AOB. Well, it sounds like a diagram is going to be a good start for this problem. So let's start with that. So let's draw some axes. So let's say 10i minus 3j, that lives somewhere down here. So that's point A at 10 minus 3. Then minus 8i plus 9j, let's say that lives somewhere up here for point B. Minus 8, 9. And then point C has position vector minus 2 plus P, so that's going to live somewhere about here if it's going to live on a straight line. Yeah, minus 2P for point B. And then we'll draw a straight line through those guys. So what we can see then is if all the guys lie on a straight line, that this vector that would go from A to B, sorry, that last point was C, sorry. So this vector that goes from A to B is parallel to the vector that goes from A to C. So we can use that property, but first to use it, we're going to need to actually work out a form for A to C, which we can do similar to how we did part A. So A to C is just OC minus OA. That's going to be minus 2i plus pj, take away, and I'm in brackets again, 10i minus 3j. Simplifying that down, minus 2 minus 10 is minus 12i, and then we have p minus minus 3, which is p plus 3, so p plus 3j. And then we know if two vectors are parallel, they must be multiples of each other, linear multiples of each other. So what we can say then is AC must equal some constant, we'll say lambda, scalar constant, lambda times times AB. So subbing in what we know, we have minus 12i plus p plus 3j must equal lambda times AB. So that would be minus 18 lambda I plus 12 lambda j. And if we compare some coefficients now, if these are two guys that are equal, the i's and the j's must be equal. So we'd know that minus 12 must equal minus 18 lambda. So that's going to give us lambda is minus 12 over minus 18, which would simplify down to just 2/3. And now looking at the j's, we'd know that p plus 3 must equal 12 lambda. And then lambda is just 2/3, so p plus 3 must equal 8. Sorry, is that right? 2/3 times 12. Yes, that's right. That's 8. Good. So then p would be 5. So that's part 1 done. Now it says state the ratio of the area of triangle AOC to the area of triangle AOB. So if we mark on the origin now, that's just here. There's two triangles going on. We have this triangle, that'd be AOC, or we could do the outside triangle there. And the thing to notice is actually this side, this side of our triangle here stays the same. So if we think about how we calculate the area of that triangle, we could use the area is a half AB sine C, and the angle we'd use has to be sandwiched between two sides. But if we take this angle, that angle's also constant for each thing. So the only thing that changes is one of the sides. So if we can see that this side that changes going from A to B or A to C scales up by a multiple, that's going to scale the area the same way if we look at this formula. So we already worked out what the scaling thing for that is. If triangle AB, the side AC is 2/3 times the length of AB. So if we want the ratio of AOC to AOB, AOC is going to be 2 parts to every 3 parts of AOB. So for part 2, the ratio of AOC to AOB is going to be 2 to 3. Carrying on to question 14, it says, find in the simplest form the coefficient of x to the 5 in the expansion of 3 plus 8x squared times 3 minus a half x to the 6. So if we think about that, we're going to need to use binomial expansion on this, and it's going to start with a constant term and go up through the powers up to the power of x to the 6. But we don't actually need all those powers because it's only asked us for the expansion of x to the 5. So if we think about the combinations of multiplication that are going to give us x to the 5, well, it would be the 5 times the order x to the 5 term, or the 8x squared times the order x to the 3 term. So in our binomial expansion of this guy, we only need to work out 2 of the terms, actually. So let's start writing that out. 3 minus a half x to the 6. Excuse me. X to the 6 with the 6 on the outside is going to be, well, the first term's easy, so I'll write that in anyway. 3 to the 6, and then we'll start forgetting about terms until we get to the ones we want. So there would be some amount of x, some amount of x squared, and now we need to actually worry about the amount of x cubed we want. So the amount of x cubed we'll get, using the formula, would be 6 choose 3 times 3 cubed times minus a half x cubed. And then carrying on, we'll work that out in a minute. I don't care about the x to the 4 term, so I'll just write some amount of x to the 4. And then now we get to x to the 5, and I do care about that. So we'll have, that would be 6 choose 5, then 3 to the power of 1, and then minus a half x to the power of 5. And the last term, I'll write dot 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 because we don't care about it, so I'll just leave it out. So let's actually get this, or this x to the 5 term. So this x to the 5 term, which is 6 choose 3, 3 cubed, minus a half x all cubed. If we plug that in the calculator, it's going to be 6, then choose 3, times 3 cubed, and then here, here, I need to make sure I put that bracket in so I get the minus sign, so minus a half, and then we'll put the x cubed on ourselves at the end, but it's minus a half cubed. That's minus 135 over 2. So we'd have minus 135 over 2 x cubed. Sorry, this is the x cubed term, not the x to the 5 term. Let's do the x to the 5 term now. So x to the 5 will have 6 choose 5, then 3 to the 1, and then minus a half x to the 5. Plugging that in the calculator now, we have 6 choose 5 times 3 times minus a half, all to the power of 5. And again, we'll put that x on ourselves at the end. So that's minus 9 over 16 x to the 5. And now we have to think about the whole expansion with this 5 plus 8x squared business. So what's going to produce the terms we're interested in? Well, it's going to be the 5 times the minus 9 over 16 x to the 5. So 5 times minus 9 over 16 x to the 5. And then we've got the 8x squared times our x cubed term. So we'd have plus 8x squared times minus 135 over 2 x to the 5. And if I pull the x times x cubed, which is going to produce us an x to the 5, if I factorize out x to the 5 from all that, it's going to leave us with 5 times minus 9 over 16 plus 8 times minus 135 over 2 x to the 5. And we can now just plug all that in the calculator. So 5 times minus 9 over 16 plus 8 times minus 135 over 2. That gives me minus 8,685 over 16 x to the 5, which would be our coefficient of x to the 5. Moving on now to question 15. It says the curve C1 has equation y equals 8 minus 10x plus 6x squared minus x cubed, and the curve C2 equation y equals x squared minus 12x plus 14. Verify that when x equals 1, the curves C1 and C2 intersect. Well, if they intersect, that means they have a common point. So the y coordinates must be the same at x equals 1. So we just have to check the y coordinates are the same. So for part A, we do that for the first curve, C1, we'd have y equals 8 minus 10 lots of 1 plus 6 lots of 1 squared minus 1 cubed, which is going to be 8 minus 10 is minus 2, plus 6 is 4, and then minus 1 is 3. So y is 3. And just check for curve 2. Y is going to equal 1 squared minus 12 lots of 1 plus 14. So 1 minus 12 is minus 11, plus 14 is 3. So we can confirm that C1, C2 intersect at the point 1, 3. Then it says the curves also intersect when x equals k. Given that k is less than 0, use algebra to find the exact value of k. Well, this information about k is about where they intersect, and we find intersection points by solving simultaneous equations. So let's start there. So just using substitution, if I substitute out the y's in the equations for curve 1 and curve 2, we'd get this line. So we'd have x squared minus 12x plus 14 must equal, let's just move that down a sec so I don't run out of space, would equal 8 minus 10x plus 6x squared minus x cubed. And then that's a cubic equation, so to solve it we're going to bring everything to one side and start to think about factors, but let's bring it all to one side first. So I'm going to move everything over to the left, so we'd have x cubed, x squared terms, we'd have x squared and then minus 6x squared, that would be minus 5x squared, and then minus 12x plus 10x would leave us with minus 2x, and plus 14 minus 8 would leave us with a plus 6, and that's all equal to 0. So now we have to start thinking about factors of this, because x equals k is going to correspond to a factor, but rather than trial and error factors, we actually already know one, because we already had earlier an intersection point, a solution of x equals 1. So x equals 1 implies a factor of x minus 1 for this cubic. So we can do long division to simplify our cubic down. So let's do some long division. X minus 1 dividing into x cubed minus 5x squared minus 2x plus 6. Let's move that as well to have a bit more space. So first we do x cubed divided by x. That gives me x squared, so I write an x squared in the x squared column. Multiplying x squared onto our divisor, x squared times x gives us the x cubed, and minus 1 times that gives us minus x squared, and then we subtract off. So x cubed minus x cubed gives us nothing, and then minus 5 minus minus 1 is going to leave us with minus 4x squared, and then we're going to write in the next term, just bring it down from here, and repeat the process. So now we do minus 4x squared divided by x, which would leave us with minus 4x. And then we multiply through again, so minus 4x times x gives us the minus 4x squared back. Minus 4x times minus 1 leaves us with plus 4x. Now we subtract off again. Minus 2x minus 4x leaves us with minus 6x. Bringing down the last term is a plus 6. And then repeating, minus 6x divided by x leaves us with minus 6. Sorry, minus 6 up here. And then multiplying through, we'd have minus 6 times the x, which would give us minus 6x. And then minus 1 times minus 6 gives us the plus 6. And it subtracts off to give us the remainder of 0. So we know we've done this correctly. So that means our cubic now must have the form of x minus 1 times the quadratic we found from our long division. So that's x squared minus 4x minus 6. And To find the solutions of that, we're going to need to solve that quadratic. So let's bring that over here. We had x squared minus 4x minus 6. And if we want the roots, we're going to, like the solutions to our cubic, the roots, we're going to set that to 0. And then to solve that, I'm going to complete the square. So let's do x minus 2, halving that middle coefficient. Square that. Then we're going to have to take away the 4 we'd get from minus 2 squared, and then put the minus 6 back in. So then we'd have x minus 2 squared minus 10 equals 0. And then if we rearrange for x, so first let's just do x minus 2 squared would equal 10. Square rooting, remember we do plus or minus for a square root. So we'd have x minus 2 plus or minus root 10. And then x would equal 2 plus or minus root 10. So it seems like there's two solutions for this x equals k, except they say k is less than 0. So we need to take the negative one, which would be 2 minus root 10. So that's our k we're actually interested in. Moving on now to question 16. It says a curve has equation y equals f of x, where x is greater than or equal to 0. Given that f dash of x equals 4x plus a root x plus b, where a and b are constants, the curve has a stationary point at the point 4, 3. The curve meets the y-axis at minus 5. Find f of x, giving your answer in the simplest form. So the info is obviously f dash of x, but what do the other 2 points tell us? Well, the second bullet point tells us 2 things, actually. If it's a stationary point, we know that at x equals 4, f dash of 4 is going to equal 0. But also we know, well, just f of 4 equals 3. So that's 2 pieces of information. And then the curve meets the y-axis at minus 5. So that's when x is 0, y is minus 5. So f of 0 is minus 5. So that's going to produce some equations for us to let us solve for a and b. Let's start with using the information about the stationary point. So we're already given the derivative. So let's just plug in 4, set it to 0, and see what that says about a and b. So if f dash of 4 equals 0, that's going to say that 4 times 4 plus a times the square root of 4 plus b must equal 0. So that's 16 plus 2a plus b must equal 0. So that's an first equation. Notice that's an equation in 2 variables. So to find the variables, we need another equation. We could solve simultaneous equations. The next bits of information, so f of 4 equals 3 and f of 0 equals minus 5, those are both points on the curve. So we need the actual function for the curve to relate the x and y coordinates themselves. So to get from f dash of x to the equation of the curve, f of x we need to integrate. So f of x is going to be equal to the integral of 4x plus a, and then the square root of x is the same as x to the half, so I'm going to write that, and then plus b dx. So then integrating, use our power rule, raise the power by 1 for x, that's x squared, and divide by that new power, that will leave us with 2x squared. Then raising the power of half by 1, that would be 3 over 2, dividing by that would be 2/3 a x to the 3 over 2. And then b will just integrate to bx. And then we're going to have an integration constant. So we've got 3 unknowns now in this equation, but we can actually use one piece of info really quickly, because what we notice about 0 minus 5 is if we plug in 0, we're just going to be left with the c. So we can find c immediately using that. So if we plug that in, f of 0 equals minus 5, that's going to produce 2 lots of 0 squared plus 2/3 a 0 to the 3 over 2 plus b times 0 plus c must equal minus 5. And then all this just goes because it's just 0. So we have c equals minus 5, meaning that f of x now is 2x squared plus 2/3 of ax to the 3 over 2 plus bx minus 5. Now we can use our final piece of information, which was that when x is 4, y, or f of 4, is 3. So plugging that in now, if f of 4 equals 3, that's going to return 2 lots of 4 squared plus 2/3 a times 4 to the 3 over 2 plus b times 4 minus 5, and that needs to equal 3. If we simplify that down, 4 squared is 16, 2 times 16 is 32, so that's 32. Then 4 to the 3 over 2, we could write that as the square root of 4 cubed. So the square root of 4 is 2, 2 cubed is 8. So it would be 8 times 2/3, so we'll say that's 16 over 3, a. And then we have plus 4b minus 5 equals 3. And then simplifying that up a bit more, if I bring all the constants to the other side, we'd have 16 over 3a plus 4b is going to equal, well, if I brought the 5 over, that would give me an 8, and then take away 32 from that. 8 minus 32. My brain's frozen for some reason, so I'm just going to put that in a calculator. 8 minus 32. Oops. It's minus 24. Cool. So now we have two equations, one from the very start and this one we just got, and two variables, so we can solve for a and b. So let's write them on the next page. I'm going to rearrange that one just to have the constants on the other side. Or in fact, actually, I might rearrange that one to just give me b, and then I can substitute. So if I rearrange that one quickly, b is going to be minus 16 minus 2a. And now let's substitute that into here. So we had 16 over 3a, and then we had 4b, so 4 lots of minus 16 minus 2a. Is it plus 4b? Yes, plus 4b. Plus 4 lots of minus 16 minus 2a. And then that was all equal to minus 24. So if we simplify that all down, we're going to have 16 over 3a, and then it's going to wind up being minus 8a, so I'm just going to plug that in a calculator. 16 over 3 minus 8 is minus 8/3. So we have minus 8/3 a, and then 4 times minus 16 4 times minus 16 is minus 64. So it's going to be minus 24 plus 64 in the end. Which is 40. So you have minus 8/3 a is 40. If we multiply by 3 and divide by minus 8, so times 3 divide by brackets minus 8, that'll be minus 15 for a. And then we had, this was our substituted thing for b. So b is minus 16 minus 2 lots of minus 15. If I just type that in the calculator again, minus 16 minus 2 lots of minus 15. That's going to give me b equals 14. Moving on to the last question, we have question 17 says, in this question, p and q are positive integers with q greater than p. Statement 1 says q cubed minus p cubed is never a multiple of 5. Show by means of a counterexample that statement 1 is not true. So we're searching for an example of p and q where we do get a multiple of 5. Well, to help us search for a counterexample, let's think about when you do get multiples of 5, subtracting two numbers generally. If you subtract a multiple of 5 from another multiple of 5, you still get a multiple of 5. For example, if I do 20 minus 5, I get 15. Still a multiple of 5. Now we have to think about, well, how can I generate some multiples of 5 that are cubed? Or cube numbers, sorry. So if I take a multiple of 5 and cube it, it will still produce a multiple of 5. Because, for example, if I take 10, that's 5 times 2. 5 times 2, I cube all that. So 10 cubed would be 5 times 2 cubed, which would wind up being 5 cubed times 2 cubed. So it has at least one multiple of, has at least one factor of 5, making it a multiple of 5. So we can play this game and just pick any example we like, really. So the one restriction we have for the statement is q is greater than p. Well, let's pick this one to be q. So I'm going to say q is 10, i.e. 5 times 2. And let's just tip p to just be 5 itself. Then if we go to demonstrate the statement's not true, we take 10 cubed and take away 5 cubed. What is that? Well, it's 1,000. Take away 125, which is 875, which is still a multiple of 5. And just to demonstrate, we can just write it as a multiple of 5. What's 875 divided by 5? It's 175 times 5. So it's definitely a multiple of 5. Then the next statement says, when p and q are consecutive even integers, q cubed minus p cubed is a multiple of 8. Prove using algebra that statement 2 is true. Well, let's define what it means for them to be consecutive even integers. So q is the bigger one, so let's start with p. So if I say p is 2n, where we'll specify n is some integer, then the next consecutive integer is always 2 along if we're going to make it even. So q would then be 2n plus 2. And now let's see what happens when we plug this form into here. So 2n plus 2 cubed minus 2n all cubed. What does that give us if we simplify that? Well, let's use the binomial expansion on this guy just to make it quick. So that would be 2n cubed for the first term. Then we'd have 3 choose 1 times 2n squared times 2. And we'd have 3 choose 2 times 2n times 2 squared. And the last one would be 2 cubed. And then this guy is just going to be 8n cubed. So we take away 8n cubed. Cool. And now let's start simplifying. Well, 2n all cubed is also 8n cubed, so that just completely cancels with that. Then 3 choose 1 times 2n squared times 2. If we just check that with a calculator so it doesn't make a mistake. So 3 choose 1 times, we're going to have a 2 squared from that 2n squared. So 2 squared, and then the final 2 on the end, so times another 2. What does that give us? It gives us 24 n squared from the n here that gets squared. So 24 n squared. Then if we do the next bit, so we have 3 choose 2, looking at this time here, that's going to be 3 choose 2 times 2 from the 2n, and then times the 2 squared at the end. That's also 24. So plus 24n plus the 2 cubed at the end, and 2 cubed is just 8. And then what are we trying to achieve? Show that it's always a multiple of 8. Well, we can see it's always a multiple of 8 because we can factorize out 8. So if we factorize out 8, we'd be left with 3n squared plus 3n plus 1. And if n's an integer, this guy must be an integer, because if we add and multiply integers by each other, we still get integers. So yeah, that's enough to demonstrate that it's a multiple of 8. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.